The air you're breathing right now, the screen you're looking at, even your own hands. It all feels pretty solid and real, right? But what if I told you that's, well, kind of an illusion? Today, we're going to pull back the curtain on reality itself and take a look at this incredible, invisible dance that connects absolutely everything in the universe. Okay, let me ask you something. Think about this for a sec. What does a star, millions of miles away, have in common with a simple stone you could pick up and a flowing stream? I mean, really think about it. One's a giant ball of burning gas, one's a solid rock, and the other's, well, water. What could possibly connect all three? Believe it or not, the answer is just one single word: matter. Yep, it's the basic building block, the fundamental stuff that makes up everything you can imagine. We're talking galaxies, grains of sand, all of it. You could almost say it's the physical language of our entire universe. So, okay, what does that actually mean, matter? Well, science gives us a really, really simple definition. It just comes down to two things. Does it take up space? Does it have volume? And does it have some weight to it? Does it have mass? If the answer is yes to both, then congratulations, it's matter. It's really that simple. All right, so to really get what matter is all about, we have to zoom in. I mean, way, way in. We're about to uncover the secret life of these tiny little particles that make up, well, everything. So let's start with something that might mess with your head a little bit. Take a block of wood, right? When you look at it, it seems totally solid, one continuous piece of wood. But what if I told you that what your eyes are seeing is just a clever illusion? We can actually prove this with a super simple experiment you could do in your own kitchen. Imagine you fill a glass with water, and you mark the water level with a pen. Now, you take a spoonful of salt, dump it in, and stir until it completely disappears. But here's the crazy part. Look at the mark you made. The water level hasn't risen at all. So, wait a second. The salt dissolved, it's in the water, but the volume didn't change? Where in the world did that salt go? And here's the big reveal. The salt didn't just vanish into thin air. It broke down into teeny tiny particles, so small that they were able to sneak into the invisible gaps, the empty spaces that were already there between the water particles. And that right there tells us something huge. Nothing is truly solid. Everything, and I mean everything, is made of tiny particles with empty space between them. So that little salt experiment just showed us rule number one about particles. There's space between them. But there are two other rules that are just as crucial. Rule 2, they are always, and I mean always, moving. And rule 3, they attract each other like tiny magnets. You get these 3 rules down, and you've basically got the key to understanding how all matter works. Okay, let's talk about rule number 2, that constant motion. Think about this. If you have an unlit incense stick, you got to put your nose right up to it to get a whiff. But the second you light it, boom, within moments, the smell has traveled all the way across the room. Why? It's because those little aroma particles are literally moving. They're zipping through the air and spreading out. It's a process called diffusion. So what's the magic behind lighting it? Well, all that movement, that's called kinetic energy. And when you add heat, like from a flame, you basically supercharge that energy. You give those particles a massive boost, so they start moving way faster and spread out much further. It's the exact same reason you can smell hot food sizzling from the kitchen, but a cold sandwich, not so much. Okay, so let's recap our 3 big rules. Particles have space, they're always moving, and they're attracted to each other. It's this constant tug of war, this battle between their need to move and their pull towards each other that creates the 3 states of matter we all know: solids, liquids, and gases. It really all boils down to who wins that battle, the attraction or the energy. In a solid, attraction is the clear winner. The particles are packed so tight, they're basically locked in place, just kind of vibrating. But then you add some energy, some heat, and they turn into a liquid. Now they've got enough oomph to slide past one another, which is why liquids can flow. Then you pump in even more energy, and bam, the particles break free completely. They're zipping all over the place as a gas, filling up whatever container they're in. See? It all comes back to those 3 simple rules. But here's the cool thing. These states aren't set in stone. They can change, they can transform. So what's the secret sauce for making matter jump from a solid to a liquid or a liquid to a gas? No surprise here, the key is energy. Again, if you want to force a change, you either have to give the particles enough energy to break free from their attraction, or you have to take energy away so that attraction can pull them back together. And our number one tool for adding or removing that energy, you guessed it, temperature. Let's follow the journey of our old friend, water. Let's start with a block of ice, sitting right at 0 degrees Celsius. Inside, its little water particles are all locked into a neat crystal structure. They're still vibrating, but they don't have a lot of kinetic energy. Okay, now let's start adding heat. But here's something weird. If you were watching a thermometer, it would stay stuck at 0 degrees even while the ice is melting. So, where's the heat going? Well, think of that energy as a key. Right now, it's not being used to raise the temperature. It's being used for one job and one job only, unlocking the bonds that are holding that ice crystal together. This is what scientists call latent heat. It's like hidden energy. And then, once the very last bit of ice melts, what do we have? A puddle of water that is still at 0 degrees Celsius. The temperature hasn't changed, but the particles themselves are now packed with way more energy, all that hidden latent heat we just added. And that's what lets them break out of their rigid structure and start to flow. So now we keep cranking up the heat. The temperature of the water starts to climb, 10, 20, 50, 80 degrees, until, bam, it hits another wall, 100 degrees Celsius, the boiling point. And guess what? Just like with the melting ice, the temperature gets stuck again. All that heat we're adding isn't making the water hotter, it's being used as more latent heat. This time, it's giving the particles a final massive shove to break away from each other completely and escape as steam. And by the way, this is exactly why a steam burn is so much worse than a burn from boiling water. That steam, even at the same temperature, is carrying a huge amount of extra hidden energy. But, you don't have to boil water to turn it into a gas. There's a much slower, gentler way this happens, and it's a kind of magic that you actually experience every single day. We're talking about evaporation. Now, here's the key difference. Boiling happens all through the water, right? The bubbles come from the bottom. But evaporation, that only happens at the very top, at the surface. At pretty much any temperature, a few of the most energetic particles right at the surface will manage to get just enough of a kick to break free and float off into the air. And this is the brilliant physics behind how we cool down. When you sweat, it's the fastest, hottest water particles on the surface of your skin that escape first through evaporation. So who's left behind? The slower, cooler ones. This actually lowers the temperature of the sweat that's still on you. Now, for that process to keep going, the remaining sweat needs more energy. And where does it get it? It pulls heat directly from its surroundings, which is your skin. The result? Your body cools down. It's like your own personal built-in air conditioner. So there you have it, from salt disappearing in a glass of water to your own body cooling itself down on a hot day. It all just comes down to tiny particles gaining or losing energy. Now you know the rules of this invisible dance that's happening all around you all the time. You kind of have the key to understanding how the physical world works. So the real question is, what are you going to unlock with it?